Right, cubes and cube roots coming to you from backstage in the auditorium. Okay, second try. All right, so test your cubing skills. This is a good time to pause the video, see if you can find the cube for the first 10 numbers. All right, if you forgot, cubing means to the third power. So 1 cubed, or 1 to the third, would be 1 times 1 times 1. All right, here come your answers. 1 cubed, 1, 8, 27, 64, 125, 216, 343, 512, 729, and 1,000. Right? Do you need to memorize these? Not necessarily, but you might want to know up from 1 to 6 off the top of your head. It's just going to make things easier. So this is not calculator math that we're into yet. All right, so cube root, symbol for a cube root, it looks like an exponent 3 just in front of a radical, and it's read as the cube root of, right? So if I had this right here with the 3, the radical symbol, and the number 64, you would say the cube root of 64. You're going to see this radical written a few different ways depending on if it's a worksheet, if it's a textbook, if it's handwritten. When it's typed in Google, the radical sign stops in front of the number. Right? But most other programs and how I write it is you'll see that the radical actually goes over everything that's underneath it. And that kind of works as a parentheses to signal to you that everything that's under that bar as part of the radical is what you're finding the cube root for. Right, so unlike square roots, there can be a cube root of a negative number. Right, so your rule for cube roots is if it's a positive number, cube root's going to be positive. And if it's a negative number, the cube root's going to be negative. Right? I'm not going to go through and explain it. You should be able to explain why. But here it is 2 different formulas. Cube root of positive n to the third is going to be n, and the cube root of a negative n to the third is going to be negative n. Okay, so how to factor a cube root? Same steps that we used for square roots. Find the factors, pick the pair of factors that has a perfect cube, split the cube root into a product of cube roots, and simplify. So for example, we're going to try and find the cube root of 128. What are our factors? 2 and 64, 4 and 32, 8 and 16. Which one of those is a perfect cube? 64 is. So we're going to split that into a product of cube roots. Cube root of 2 times the cube root of 64. And then we can simplify. Cube root of 64 is going to be 2. No, cube root of 64 is going to be 4, sorry. So we get 4 times the cube root of 2. Now I want you to notice how I have it split up over here. And it's not just next to each other. 4 times the cube root of 2. Right? If you smush it all together, it could end up looking like 4 cubed times the square root of 2. So you got to be really careful, either if you're typing or if you're writing, that it's clear where that 3 goes. So for the rest of these slides in my examples, I'm going to separate them with adult multipliers. So it's always clear where the coefficient is and where the cube root is. Let's look at some examples. So the cube root of 128. Our factors are going to be 2 and 54, 3 and 36, 4 and 27, 6 and 18, 9 and 12. There's only one of these that's a perfect cube. Do you see it? It's going to be 27. Step 3, we're going to split into a product of cube roots. So we get the cube root of 4 times the cube root of 27. We can simplify that. Cube root of 27 is 3. Cube root of 4, and we end up with 3 times the cube root of 4. Next, we got cube root of 424. What are our factors? We got 2 and 212, 4 and 106, 8 and 53. Which one of those is a perfect cube? It's 212. So step 3, we're going to split into a product of cube roots. So we get the cube root of 2 times the cube root of 212. Right? So the cube root of 424 ends up being 6. That's the cube root of 212 times the cube root of 2. Right, so you give it a try. What have I got? I've got the cube root of 448. I'm going to give you a moment to pause. Okay, so I still go through and show you all the steps for these. All right, there's your factors. Which one has a cube in its factor? There we go. It's 7 and 64. So we split it into 2 cube roots. And we end up with 4 times the cube root of 7. Another one, cube root of 120. Okay. Split it into factors. Lots of factors here, but only one of them is a cube, right? It's 8, so we split it into a product of cube roots. Cube root of 8 times cube root of 15. We end up with 2 times the cube root of 15. Adding variables, same thing that we did with square roots, right? Find the factors of your coefficient, and then you're going to find your factors for your variables. Find pairs of factors that have perfect cubes, split it into a product of cube roots, and simplify. So we're going to start with 16x to the third y to the fourth. Okay, so what are my factors for 16? I've got 2 times 8, 4 times 4, right? X times x, which would be x to the third, and x to the third times x. So if we pick 2 times 8, 8 is going to be our perfect cube. X times x times x, that's x to the third. That's a perfect cube. And y to the third times y. So y to the third is a perfect cube. So we split that up into a product of cube roots. We've got the cube root of 2 times the cube root of 8 times the cube root of x to the third times cube root of y to the third times cube root of y. Simplify what we can. We end up with 16. Oh, see, I forgot to put the cube root up here. Anyway, pretend it's there. I'll fix it. The cube root of 16x cubed y to the fourth is 2 times cube root of 2 times x times y times the cube root of y. So we end up with 2xy times the cube root of 2y. Right, so our examples. Dang it, I got to stop it again. Exit. I'm going to pick it up. Oh, you weren't supposed to see all that. Stop.